So the left side, that's what I mean by start. And end up. And by end, I mean the right side goes up. Okay, so I'll even highlight so that you guys can see more clearly what I'm talking about. So start down, I'm referring to this, that side going down. Let me make this bigger. And then by end up or right, I mean this piece. Okay, so that arrow is going up. Whew. Okay, so then it says the end behavior of these graphs is, so it decreases on the left and increases right. Okay, so that's what it's asking in part B. And then part C says change your leading coefficient to be negative. What does it change about the graph? So let's start with the middle function that we had. So I'm going to unhighlight the red function so that I don't see it anymore. I'm going to go ahead and make this negative, and it flips the direction that the ends go. Okay, so let's see if that happens the same with this. So here's the positive, here's the negative. So it flips the direction of each end. So instead of going down and then going up, it changes to going from up and then to down. Okay, so this was our left that was decreasing, this is our right, and it switches the direction that we're going. Oops, you guys can't see. Okay, so do you see how the pink was going down and now the pink is going up? The yellow was going up, now the yellow is going down. Okay, so this is what adding the negative does. So with the even functions, both ends were going up and then both ends were going down. With odd functions, we go from down, up, and then when we add the negative, we switch, and then they're going up and then down. Okay, so that's the difference between this. Let's flip over. So it says in Desmos, graph a quadratic function, add sliders, and then it says, what is the degree of a quadratic function? Everybody should know our quadratic function has a square. That is the highest power, so our degree is 2. I guess I should follow the instructions and go ahead and put my function in. So y equals x squared plus cx plus d. And I want to add all my sliders. Okay, so I have this function right here, and it says, what is the most x-intercepts that you can create? So if I play with the c keeps my y-intercepts the same and kind of like moves where my function is. And it looks like no matter what I do, I end up, my max x-intercepts end up being when my minimum is below the x-axis. I can also change my d value. This shifts my function vertically, okay? So I could shift all the way down until I have 2 x-intercepts right here. So my max x-intercepts for my quadratic function are going to be 2. What is the most turning points you can create? No matter what we did, our quadratic function mostly stayed the same shape, or yeah, pretty much stayed in the same shape. And so this means that the max turning points are going to be 1. Okay, so then for this next one, I'm going to add a b in front of my x squared, and I'm going to add an x cubed as well, and plus. And I want to add my b slider. Okay, so this time I can play around and see what my B does. My B kind of made it curvier. I can make my D and make it shift up. My C still keeps the y-intercept the same, but like stretches it out a little bit. So the degree of our cubic function, highest leading power, or highest power up here is 3. There was 3, 2, and 1. 3 is the biggest out of those 3 numbers. So our degree is 3. The most x-intercepts I was able to create was when it passed through 1, 2, 3 times. Okay, notice that I can force it to only pass through one time. I can make it, oops, what did I do? Whoa, cool. I can make it hit exactly twice. Ooh, I was so close. Nope. Sorry, I'm playing with it. Okay, well, I can make it hit exactly twice. Okay, there we go. So one time right here and one time right there. And then as you saw, I can also make it pass through those 3 times. So our most x-intercepts we can create is 3. And the most turning points we can create, we created 1, 2. We can change our b around so that it doesn't really have any at all. But the most that we could make was when it was curviest was 2. Okay. Now we're going to do the same thing, adding an x to the 4th, and then plus ax cubed, and I'm going to add this slider. Okay, so now if I play with my a, oh, I'm going to try to make it really curvy. Okay, so here I was able to get it to pass through 4 times. And so when it's at its curviest is when it's going to have the most x-intercept. And so if I shift this around, I can get it to have 2, I can get it to have 0, I can get it to have 1, I could get it to have, if I can get this one to touch exactly on the right-hand side, I could get it to have 3, and then if I push it down even more, I can get it to have 4. So my most x-intercepts is going to be 4. My biggest power here is 4, so my degree is 4. And the most turning points that I could create when it was like the most curvy was 3. So I have 1 here, 1 there, 1 there. So my most turning points is 3. Okay, so then in this table, we want to summarize. We already wrote out all of our functions. This was degree 2, degree 3, degree 4. Max number of turning points was 1, 2, and 3, and x-intercepts was 2, 3, and 4. Okay, that's this table. Notice these are all 1 less. So the degree value is always going to be equal to the max number of intercepts. Okay, and then the turning points are max turning points. So you can always have less. Is going to always be equal to the degree value minus 1. Okay, so we took this degree value, subtract 1, and you get my max number of turning points. 3 minus 1 is 2, 4 minus 1 is 3. Okay, so our summary, it says if a function has degree n, so the max number of turning points will be n, because that's the degree, minus 1, and the max number of intercepts is going to be n. Okay. And then also, don't worry, I'm going to post also a scan of the full solution so that if you, well, you can always pause the video, but if you didn't catch something and just want to look at something that's not moving, you can always go back. Okay, so let's flip this over. So step 6 says use Desmos to graph the cubic function, and we want to add all of our sliders. So I'm going to get rid of all this stuff in Desmos, and I'm going to type in what I have here. X plus P, X plus Q, oops, sorry guys, and then X plus R. Okay, and I'm going to add all my sliders. Okay, so then it says, okay, click the points where the graph crosses the x-axis so that Desmos shows you the x-intercepts. So here's one, okay, -1, 0. All of these were at 1. Let's change them so that they're different. Okay, so let me get these to be whole numbers. I wish I could, I want this one to be 2. There we go, our -2. Let's make this one +2.